So I'm looking at our recorded data on this trial, and I think mostly because I'm further away from the camera in the previous throw, but it's looking at this data is pretty noisy. So to take a look at it in detail, let's go ahead and plot out a section of this. And we'll try and go not from the very beginning, but somewhere into it so we can use the same time scale for our velocity and our acceleration. And right now I'm going to look primarily at the vertical position. So let's look at that range will work out good. We'll look at position. So I'm going to plot that. So that's the position of the ball. And it looks okay, but again, we do have some gaps here in our recording that are really large and some that are a little smaller. But again, some ranges there that are not quite consistent in terms of the frame rate of the data that's being recorded. Let's also go ahead and format this the way we want it before we continue to create more charts. So I like to have my charts to have their axis titles, and I'll make this position. Let's call it vertical position in meters. And I'll call this time in seconds. And then I'm actually going to copy this, highlight a new cell, and then paste it again. I'm using Control C to copy and Control V to paste, but you can also right click and then click on copy. Click and then right click and click on paste. And it'll give you the same thing. And then to get the velocity, all I'm going to do is I'm just going to drag this over. So the position, there's some gaps here, but it still looks pretty smooth. The velocity, again, a couple of gaps, but still pretty smooth. You can see that I kind of crouch down and then I start accelerating it up. There's a peak in acceleration somewhere around here. And then I let go of the ball, and then it slowly decreases in velocity as it goes through its arc. So that still looks pretty good. Again, I'm going to copy this using Control C. Let's go ahead and fix this before we go on to the next one. Vertical velocity. It's going to be in meters per second. And let's paste it in again. And again, I'll just slide this over. And actually, if I wanted to, I'm probably not going to use this horizontal position, velocity, acceleration inside this example. So if I wanted to get rid of that, I could. And if we look at this velocity chart here, this actually looks really noisy. So I'm going to go through, I'm just going to change this to acceleration. This is meters per second squared. And so if I want to try and use this data to predict the forces inside the model, it's not that great just because it's so noisy. So what I want to try to do is I'm going to try to do a little bit of filtering to try and get rid of some of the noise inside this data. Because I don't have a very even sampling rate, this may be a little tricky, but we'll go ahead and do it anyways. So rather than adding this here, I'm just going to go ahead and insert a new value, or a new set of values. And actually, let's leave our original values there. Let's move these over to the side a little bit so we can reference them if we want to. I'm going to make this my filtered position. And actually, because my time samples are not even either, I'm probably going to have a filtered time too. I'm just going to call it F time. Still in seconds. And I'll use the same X and Y headers. And the easiest way to filter data is to use a weighted average of the values around the points of interest. And the larger the range of values, the more aggressive the filtering. So let's start with kind of as minimally aggressive as we can get. Let's just do average of 3 values. And again, I'll do the same thing for all my data here. Now again, I don't want to use the one above here because, again, just like when I did my forward difference, I don't want to take an average of the headers. I just want the values inside it. Then I'll drag that all the way down. And actually, to be able to use the same filter for all of these, I can go ahead and just delete that. Now, I can filter it and then I could take the forward or backwards difference, or I can filter it, or I can take the difference and then filter. The order doesn't really matter in this. So if you filter derivative, that's the same as if you derivative filter. There are some kind of kinks in that can throw that off a little bit, but for the most part, that's going to be pretty true. And I'm actually going to copy this chart and then paste it in again. And now I have two charts on top of each other. I'm just going to drag this one over. So it's actually the filtered X. And the filter, I want to get the filtered Y too. So this is the superposition of the filtered and the unfiltered data for position. I'm going to do the same thing for the velocity. I'm just going to click on the time series, copy, and paste it in. Now I've got two time series on top of each other. I'm just going to drag this across. Actually, I haven't calculated the filtered values yet, so I'll do those too. But again, I can use the same filter for all kind of four of my outcomes here. So again, that's going to filter the velocity. This is going to filter the acceleration. And again, I'll drag all those down so I have the entire time series. And this is the kind of situation where you might get to the point where you calculate things and then you figure out you can get a little bit extra data. And so you go back into the Keynote VDO software, right? And you get a few more points before or after the activity. So that way you can filter more aggressively as you move down. I'm not sure which of these is which at this point because I just moved them down. So we probably should format this series a little bit more consistently or label them so we know which one's which. Although in these two, it's a little hard to tell the difference because they're so on top of each other. But let's still go ahead and do that. So I'm going to add legends to this. And I'm going to edit the data for this. And I see that series 2, if I edit this, this is D and G, which is my unfiltered, right? So this is unfiltered velocity. I can say unfiltered because they're all velocities. And then this one here, if I edit this, I can see this is N and K, so this is the filtered version. And so I know which one's which in that case. Although a lot of times it's pretty obvious which one is filtered and which one's unfiltered. And then the one that I really cared about, was the reason I'm really kind of doing the filter at this point, is this acceleration data, which is super noisy. So I'm going to copy that. And then move these across. Should be that one right there. Again, I want to move my time series across as well. And let's move our headers across so we can have those as well. And we see here in this one that the filtered data is a lot cleaner than my unfiltered data. I'm actually going to change the axis options on here so I can look at this a little bit closer. Let's make the maximum 65 and the minimum -20. And we see here with this, we have a pretty consistent acceleration of around -10 going up, and then a little less than that coming down, which makes sense. Probably still a little bit noisy. I might filter this a little bit more aggressively if I wanted to get a better idea of what kind of the drag forces were and stuff like that. But for now, I think this will work good. And there's kind of a trade-off here is that I know I have a peak in the throw, in the acceleration of the throw right here at this jaunt. But there's some noise in this kind of parabolic arc here. If I filter too aggressively, I'll lose any peak I have in here. And so the true maximum force that I exert is going to get lost, right? So this value here, the maximum values are going to come down and down and down and down and down the more I filter because they have a very short duration. Whereas the ones here that are they're still kind of oscillating, it would probably be good to filter those. So you have to kind of select filters that are appropriate for your activity, but just use your best judgment in this case. And again, we'll have classes that talk about those in a little bit more detail inside the curriculum if you come in and be in the bioengineering program. All right, so let's actually talk about getting our outcomes in the next video.